Lecture 1.3 Understanding the Scientific Evidence for Essential Oils as Natural Insect Repellents. Throughout history, aromatic plants have been used to discourage insects from homes, clothing, and outdoor living spaces. Long before synthetic insect repellents existed, people burned aromatic woods, scattered herbs around their homes, and rubbed fragrant plant oils onto exposed skin. Today, science allows us to investigate many of these traditional practices and ask an important question: do essential oils really work as insect repellents? The answer is both yes and not always. Some essential oils have demonstrated promising insect repellent activity in laboratory and field studies, while others are supported mainly by centuries of traditional use and smaller scale research. Understanding this distinction helps us make informed decisions and communicate responsibly with clients or students. Before we examine each oil individually, it's useful to understand the different types of scientific evidence. Types of evidence: not all research carries the same weight. Generally, scientific evidence progresses through several stages. Traditional knowledge. The earliest evidence comes from traditional use. If communities have successfully used a plant for hundreds of years, that history deserves consideration. Traditional knowledge often provides the starting point for modern scientific investigation. However, tradition alone does not prove effectiveness. Laboratory studies researchers next examine essential oils under controlled laboratory conditions. These studies often investigate whether insects avoid an essential oil or whether certain chemical constituents interfere with insect behavior. Laboratory studies are valuable because conditions can be carefully controlled. However, laboratory results do not always reflect what happens outdoors. Field studies. Field research evaluates how well an essential oil performs under real environmental conditions. Researchers may compare volunteers using different repellents while measuring the number of insect landings or bites over time. These studies provide stronger evidence because they reflect practical use. Systematic reviews. The strongest evidence comes from reviews that analyze numerous studies together. These reviews allow scientists to identify consistent findings while recognizing differences between studies. This provides the most reliable picture of how effective an essential oil is likely to be. What makes an essential oil repellent? Essential oils are complex mixtures containing dozens or even hundreds of naturally occurring chemicals. Some of these volatile compounds interfere with the sensory systems insects use to locate their hosts. Many biting insects rely on detecting carbon dioxide, body heat, moisture, skin odors, volatile organic compounds released from our skin. Rather than killing insects, many essential oils simply make it more difficult for insects to recognize us as a suitable host.
Essential oils with the strongest scientific evidence. Citronella. Citronella remains one of the best-studied botanical insect repellents. Its primary constituents include citronellol, citronellol, and geraniol. Numerous studies demonstrate that citronella can reduce mosquito landings, although its protection tends to decline after 1 to 2 hours because the oil evaporates relatively quickly. For this reason, citronella often performs best when combined with fixative oils such as cedarwood or vetiver. Evidence rating: 5 stars. Lemongrass. Lemongrass contains high concentrations of citral and related aldehydes. Research consistently demonstrates mosquito-repelling activity, particularly when used within blended formulations like citronella. Repeated application is usually necessary. Evidence rating: 4 stars. Lemon eucalyptus. Lemon eucalyptus deserves special mention. The essential oil itself contains citronellol. However, the compound PMD, paramenthane 3,8-diol, produced from citronellol, has undergone extensive scientific testing. PMD-based repellents are recognized internationally as effective botanical insect repellents. It is important to understand that pure essential oil is not identical to PMD products. Evidence rating: PMD 5 stars. Evidence rating: essential oil 4 stars. Lavender. Lavender has demonstrated mild to moderate insect repellent properties, although not as powerful as citronella. Many studies show reduced mosquito activity around lavender-treated surfaces. Its pleasant aroma makes it particularly popular in personal blends. Evidence rating: 3 stars. Peppermint. Peppermint contains menthol and menthone. Several laboratory studies demonstrate activity against mosquitoes. Ants and some biting flies. Its cooling sensation also makes it popular in post-bite preparations. Evidence rating 3 stars. Tea tree is valued primarily because of its antimicrobial and skin-supportive properties. Although it demonstrates some repellent activity, it is often included to support skin care after insect bites rather than serving as the primary repellent ingredient. Evidence rating 2 stars. Geranium contains citronellal and geraniol compounds associated with insect repellency. It blends exceptionally well with citronella and lavender and contributes to both fragrance and overall repellent performance. Evidence rating 3 stars. Cedarwood has long been associated with repelling moths and other insects. Its slower evaporation also makes it an excellent fixative, helping extend the longevity of more volatile citrus oils. Evidence rating 3 stars. Oils supported mainly by traditional use. Several oils have encouraging preliminary evidence, but fewer large human studies. These include basil, cypress, pine, vetiver, patchouli, melissa, galbanum, chamomile, thyme, clove. These oils often contribute valuable fragrance, blend stability, or complementary repellent effects. However, scientific evidence remains less extensive than for citronella or PMD-derived products. Why blends often per.
One fascinating discovery is that carefully designed blends frequently outperform single oils. This is because different chemical constituents evaporate at different rates. Combining citrus oils, herbaceous oils, and woody base notes can provide broader and longer-lasting protection than using a single essential oil alone. This concept is known as synergy and is one of the strengths of aromatherapy blending practical reality. It is important to remain realistic. Essential oils are not magic shields against biting insects. Most provide protection for shorter periods than conventional repellents because their volatile compounds evaporate relatively quickly. This means reapplication is often necessary during prolonged outdoor activities. Essential oils should therefore be viewed as one component of a broader insect avoidance strategy that includes suitable clothing, awareness of insect activity, reducing standing water, and sensible outdoor behavior. Summary: as aromatherapists and informed users, our goal is to combine traditional botanical knowledge with modern scientific understanding. Some essential oils, particularly citronella, lemongrass, and PMD-derived lemon eucalyptus, have good scientific support for insect repellency. Others continue to show promise and have been valued for generations. Even though more research is needed, by understanding the strengths and limitations of the evidence, we can make balanced, responsible recommendations while continuing to appreciate the remarkable contribution that aromatic plants make to natural outdoor well-being. Key learning points. By now you should recognize that different essential oils vary in their effectiveness against different insects. Citrus, herbaceous, and woody oils are commonly combined to improve aroma and performance. Scientific evidence supports the insect-repelling properties of several oils, particularly citronella, lemongrass, and certain eucalyptus-derived products, while others are supported mainly by traditional use or smaller studies. Essential oils work best when combined with sensible outdoor practices such as appropriate clothing, avoiding peak insect activity, and eliminating standing water where possible. In the next lesson, we'll examine the scientific evidence behind these essential oils in more detail, helping you distinguish between traditional knowledge, laboratory research, and practical real-world application.